Hello everyone, in this video we'll be looking at simple molecules, or what some people call covalent compounds. Right, at the end of this lesson, you should learn how to link the physical properties with structure and bonding in a simple molecule. State the structure that is present within a simple molecule. State what particles are formed in a simple molecule. State what bonding is found in a simple molecule. And define what is a covalent bond, and distinguish what's a covalent bond and what's a weak intermolecular force of attraction. And you also need to explain why simple molecules have low melting points, and also explain why simple molecules cannot conduct electricity in any state. So let's first start with simple molecules. I like to call it simple molecules because not all simple molecules are compounds. But some books do use covalent compounds, so I'll use both words interchangeably. Simple molecules and covalent compounds. So we have found out that actually simple molecules have a low melting and boiling point, as well as they cannot conduct electricity in any state. And as what we have discussed before, when something has a low melting or boiling point, it means that the attractive forces are weak and I need very little energy to overcome these forces. And if I cannot conduct electricity, means that simple molecules have no charged particles. So, based on these clues, what do we know about simple molecules? Simple molecules consist of molecules that are made up of atoms. Notice that molecules and atoms, right, they are all non-charged particles and therefore cannot conduct electricity. What are the bondings present? This is very unique, right? There's actually strong covalent bonds between the atoms, and these are the chemical bonds between the atoms. Right? However, when the atoms chemically bond together, they form molecules, and these molecules will interact with each other weakly. These are the weak intermolecular forces of attraction. So how do I describe the structure of a simple molecule? Simple molecules are therefore molecules with weak intermolecular forces of attraction between the molecules. So let's take a look at this diagram over here. You can see that in liquid state, the molecules are just rotating around their position, sliding over one another, and you can see that the red circle is chemically bonded to the blue circles, right? And in gas mode, they are just flying everywhere very quickly. The blue circles and the red circles still remain chemically bonded together, right? However, the distance between the particles, the molecules, in fact, over here, increases. So this on the right is the drawing, it's a picture diagram of how a simple molecule will look like. And you will notice that there are 4 molecules over here. So what are these diagrams representing? So these circles are the atoms, right? And these atoms make the molecule. And you realize that 3 atoms together here make the molecule, and they are joined by this solid line. And this solid line is actually the strong covalent bonds, the chemical bonds that doesn't break. Right? And these molecules are actually joined by these dotted lines, and these dotted lines are the weak intermolecular forces of attraction, which can be easily overcome and they can be pulled apart, like what you can see in the liquid state to the gas state. So covalent bonds are actually very strong, and they are actually stronger than ionic bonds, right? And these are formed when non-metal atoms, right, share electrons with each other. They form chemical bonds with each other. So a H2 molecule actually consists of 2 hydrogen atoms covalently bonded together, and a H2O molecule actually consists of 1 oxygen atom that is covalently bonded to 2 hydrogen atoms. Right? Covalent bonds are so strong that they are never broken except during chemical reactions. There's the weaker force that is present, right, which is called the intermolecular force of attraction. The name intermolecular, inter-school, between school, interclass, between class. So intermolecular means between molecules. And these are the weak forces that are between molecules, right? And these are the forces that during physical changes like melting, boiling, condensation are actually overcome or formed, right? And there is one factor that is very important that will affect the strength of the intermolecular force. The larger the relative molecular mass, the stronger the intermolecular force of attraction. So if you compare the group 7 elements, chlorine, bromine and iodine, chlorine having the lowest relative molecular mass have the weakest intermolecular force of attraction, and iodine, the one with the highest relative molecular mass, have the strongest intermolecular attraction. So now that we understand it a bit better, it's time to explain why simple molecules, right, have a low melting and boiling point and cannot conduct electricity in any state. So the question says, explain the low melting point in carbon dioxide, right? And therefore would be what we're explaining. Therefore, carbon dioxide has a low melting point. And previously we have learned that when there's a low melting point, it will mean that there are very little energy required to overcome the forces, whatever these forces is. Now, in simple molecules, it's a bit tricky because you need to decide whether it's covalent bond or whether it's weak intermolecular force of attraction. But you should know that covalent bonds never break unless it's a chemical reaction, right? So in this case, we say, since there are weak intermolecular forces of attraction between carbon dioxide molecules, and as little energy is required to overcome these forces, therefore carbon dioxide has a low melting point. Right? Please remember this. Next, the question says, explain why water cannot conduct electricity in any state. So how are you going to explain this? So let's start with the therefore. So therefore, water cannot conduct electricity in any state. And we have learned previously that if something cannot conduct electricity, means that there are no mobile particles present. And in this case, we want to be specific and indicate that there are no mobile ions. Right? No mobile ions present. And why are there no mobile ions present? So you said, since there must be mobile charged particles present to conduct electricity, and water exists as a simple molecule. And as there are no mobile ions present, therefore water cannot conduct electricity in any state. So these are what you need to know about simple molecules, right? I hope that has helped you. Please practice a lot and so that you can remember this. All the best. Bye bye.